Next talk is Matt Good, templating your Terraform. Matt is an infrastructure engineer at Glider Labs, developing components for container-based infrastructure. Let's welcome Matt.
Yeah, so talking today about a piece of software we wrote called Cellstack that I think could be categorized as like the less is more service stack, kind of striving for that Unix ideal of building software from like small reusable components. They're all kind of simple, easy to understand on their own, and then you can kind of combine them together into something really cool. So Glider Labs is the creator of Cellstack. It's an open source project. And so Glider Labs is a small consulting firm, mostly focused on Docker-related infrastructure components. Most of what we do is open source, and then work with clients to help them set up their infrastructure based on it. So you might be familiar with the Docker Alpine image, which has been really popular for creating small Docker images, compared to, like, say, your Ubuntu, which is like hundreds of megs. The Alpine image, you start off with, I think it's like 5 megs or so, and can build off of that with, you know, a packaging system that still works. So it's great for building small Docker containers. It's what we use for all of our Docker infrastructure. And so Cellstack started with a set of open source infrastructure services that we had worked on. These are all open source, and again, they work well on their own. Lots of people are using 1 or 2 of these, but when you kind of put them all together, they can provide a very fully featured service discovery-based infrastructure in a way that is transparent to the actual application code running in the container. And we use the Docker metadata. We'd been using environment variables mainly to configure how, you know, to work with your containers. Now starting to move toward Docker's labels, since it's a little better suited for what we need. So Docker has this great events API, which is one of the nice reasons to build on top of the Docker platform, is we can watch for when containers start and when they die. And so we know what's running at any time in your system and can work to coordinate your containers across the infrastructure. So Registrator is one of the more popular projects that we've worked on. And so it helps automate your service registration by watching what containers are running and then can inject them into your service discovery. So setup might look something like this. So you've got Docker running, you have a handful of containers, and you have Registrator monitoring them through the Events API and can automatically tell the Consul agent about them, and then that keeps them synced with the Consul cluster. And the other one that's pretty popular is Logspout. Works in a similar manner, but instead when a container starts up, it'll start capturing the logging output through the Docker API and post that to your log aggregator. So now you have service registry and log streaming and transparent to the actual code. So these next two probably haven't seen before. They're a little bit newer and not as well known, I think partly just because people don't realize how they kind of fit together with the rest of it, and that's one of the things that we're trying to address with Cellstack. So Resolvable was built to solve some of the problems that we were having with container DNS. Docker does let you configure DNS specific to the containers, but you have to reconfigure the Docker daemon, which may mean restarting it. And so we decided it would be easier to just hook in by updating the host resolve.conf. I mean, that's optional if you want to or not, but we can automatically inject Resolvable at startup into your DNS. And then out of the box, we can recognize the containers and let you look them up by name in DNS. So the container foo would be foo.docker. And so that's nice for some situations, a little bit more flexible than Docker's links. It's more dynamic, and so it's not order dependent, so you can look up any other container running on the same host. But really, we want to be able to talk to containers across hosts as well. And so with the Consul agent running in Docker, we can set some flags on the agent that tell it that it provides DNS for the .consul domain. So then Resolvable sees that the Consul agent can provide DNS, and when you make a query, it goes through Resolvable and will get forwarded to Consul agent. So now, with Registrator on the one hand, registering all your services in Consul, and Resolvable letting you look them up through DNS, we have most of what we need to do kind of the whole nice service discovery, except unfortunately, especially with Docker, DNS has some limitations, in particular with ports. So DNS, when you look up a service, you get the address, and most things just assume you're going to connect on a well-known port, or you have some pre-configured port. With the Docker NAT, of course, you don't. You have some ephemeral port that Docker's allocated for you, and we can store that in the service discovery, but if you want to connect to that port, you have to have some alternate way beyond just the typical DNS A record to know what that is. And that's where Connectable kind of completes this. So DNS has another type of service, another type of record called service records. And service records are perfect for what we need. You know, it has the address and the port, except most of our client code doesn't work with service records. You know, you specify a host name, it's just going to look up the address. You could write some special client code to do that, but that gets kind of messy, and maybe you're running some third-party software that's not even an option. So Connectable implements what's called the Ambassador pattern. And so it basically acts as a proxy that knows how to talk to the service backends. And so through setting up some IP tables rules, you can say, I want to connect on port 1234, and I want that to go to this service. And this is, again, configured through the Docker metadata. And so then Connectable sets up, you know, the rule, and it sends that traffic to itself, and then can load balance that across different backends, looking them up through the DNS service records. So for a typical client setup, we'd be deploying with Terraform, CoreOS, and Amazon. And you know, we were finding these tools working pretty well, but then when it came to deploying them, there were similar things that we were doing and some things that we just found were repeating ourselves, and wanted to combine that into a nice kind of cohesive system that, again, was fairly simple to use and to modify, and that's where Cellstack started. So I'm going to go through kind of the code and how to use Cellstack, and I'm going to set up just simple infrastructure here, running some stuff on Amazon. We're running a 3-node Consul cluster. Ghost is just a simple logging platform. It was just a nice demo app, web service. We'll run 3 of those with an Amazon load balancer and a Postgres database that the Ghost blog will store its data. So hopefully I got the sizing on this kind of readable. So Cellstack comes with some default configurations for those services that I talked about before. We also included some common things that we were using a lot, like for the Elk, Elasticsearch, Logstash, Kibana stack, and Consul, of course. So we use a tool called Gun, which it doesn't do much by default, but it's made to just, you can write modules within your system, and it's just a wrapper to the set of commands that you're going to use. So in particular, when you automating some operation stuff, you're going to have sets of commands for different tasks that you want to automate, and Gun's just a little wrapper to that given a gun file in the current directory, it'll pick up on the modules. And so now when we run gun, we're going to get, oops. Sorry. Now when we run gun, we'll get some actual commands here. So some of these might be familiar for the Terraform commands that they're wrapping. So a Cellstack environment we'll call a blueprint. We'll define the services, the infrastructure services that we want to run. And so when we generate a blueprint here, so we'll create one called live, which will contain a set of infrastructure. By default, it has a thing here just setting some environment, pointing to the VPC setup, so just some standard Amazon gateway rules, security groups, that sort of thing that we were repeating across all of our client setups. And then to use this, we want to create a profile. So your live environment, you may want multiple instances of that. You want the actual prod one, and then you may want one for stage, different types of testing or development environments. And so again, we're just using environment variables here, and we'll save it to a file that Gun will recognize as a profile. So the next time that we run Gun, we can specify the profile name that'll load up. And we're going to run a Terraform plan for the prod profile, which we need to go and configure our credentials here so that it can talk to Atlas and Amazon and all that. So this is an example of, just some environment variables that you would need for the credentials for the different services that you want to communicate with. And so we'll load that in our profile. I have not included my Amazon credentials in this talk, so they're just stored in a separate file that we're going to source. And for demo purposes, we'll just override some Terraform variable here to say that we just need some micro instances. We don't need anything big. And now our plan should actually set up that Amazon network that we were showing. So we can apply, and Terraform will go and configure the networking. So of course, next, we're going to want to actually set up some servers on here. So configure that by adding some components to the blueprint, which come from the infra folder. So there's a few things here. Some of them are defaults. A few are things I've added for the demo. For Consul, we're going to run a typical 3-node cluster, and this just configures some things like security groups and so on. So when we add it, we're using CoreOS, and so we don't actually deploy the software directly, or we don't install the software directly to it. We let CoreOS read in the user data config, which sets up the systemd units, and that'll define what to start, and it'll load everything. So we start with an empty config that will start filling in the template for. So we have some basic cloud config here, and with our templating system, we'll set the Consul server cluster size to 3. And so we just have a few templates that we're including. The host template defines kind of common stuff that goes on all hosts. And then the service template is a way to include particular services that we've defined. So now, so this is where the Cellstack commands start to come in, is when you run a plan, it'll generate the templates and we can look at the actual output. So this is all of the code that we're saving ourselves from writing, unit descriptions and so on, just by including some templates to define what's going to go on the host. But, like I said, a lot of these are kind of common services we're going to run everywhere. And we refer to those types of things as agents. So we have a convention for a YAML file that can define agents that run on every host. And the host template will automatically insert all of those. So configuration will still have resolvable and registrator coming from that agents.yaml file instead. And we can include the rest of the ones we talked about, like log spout, connectable, and then the Consul agent. So on the Consul server, we probably don't need to run an agent as well, so we'll tell it to just go ahead and skip installing the agent. So let's take a look at the templating system. So this is what's in the host template. We have two targets, just one for all of the kind of high-level services, typically your application services, and then the early services. And then we include this agents.template, which just simply parses the YAML file and includes that service template that we saw before with the service name. And then the service template kind of takes care of all of that boilerplate systemd unit description for all of our Docker commands to start up the services that we're running. Oh, there it goes. So we define the actual parameters for what Docker image and command to run in a YAML file as well. And so by separating this out, we reduce a lot of that boilerplate, and then we'll see a few other ways that we can reuse this more structured way of defining our units later. And so this is just the Docker command for the Consul server. So now we can apply, and it'll actually set up our Consul cluster for us. So similarly, we can add Postgres, which, again, we start with the empty host config, and we'll just customize that template that we saw before. So we'll add the Postgres service. And Terraform apply again. So of course, Terraform recognizes things we're already running, and we'll just additively start up the new things that we've added to the configuration. And now we've got a Postgres server. And finally, we'll add the Ghost service. So the Docker config for Ghost has a few other things that we've included here. One is a simple way of kind of checking that services are running. We do a DNS lookup in Consul. So once we've known that it's registered in Consul, that service is probably running. We should be able to talk to the Postgres service. And then this connect line here, so this is a Docker label that I talked about. So this is what Connectable looks for. So by adding this on your service, Connectable recognizes you want to connect port 5432 to the Postgres service console. And so it sets up all the firewall rules and routes traffic to that backend. So you see the DB host is a parameter here. So the way Connectable works, since it's adding these IP tables rules, you're actually connecting on localhost. So it's the container's local host, port 5432, that we're connecting to. And so we can set that as a config in the host config, saying we want to connect on DB host, localhost. And apply again. Now we've got Ghost running. And through our service discovery, it's going to be communicating with the Postgres backend automatically. And we configured a Amazon load balancer in the Terraform for this so that we can easily connect to it and get to the blog that we're running, which we could go and configure on the admin UI, but this isn't really about Ghost, so we'll just move on. So one of the nice things that I mentioned about structuring the Docker config in a way that we can parse. So CoreOS, again, it runs a just very basic system running Docker, and then when we start up, it's Docker that's pulling in all of this data. So when you go to start a service, it downloads everything, but it might be nice to install all of those ahead of time. And since we have it all stored in a structured format, we can use Packer and tell Packer to go and pull those Docker images, save a snapshot, and then we'll start all of the rest of our images based on that image. So we're just pulling in all the Docker images and then saves an AMI for us, which is appended to our profile so that the next time that we run Terraform, it'll pick up on this base AMI to run for the services. And then that abstraction also gives us an easy way to configure Vagrant given the same files. So we can template our Vagrant config and add in on a single server all of the stuff that we want to run: Consul, Resolvable, Registrator, Postgres. And since we're running on a single host, Connectable actually, we don't even need to run Connectable here. We can use the Resolvable DNS address for the postgres.docker. So that's just looking based on the container name. And we can communicate directly with the Postgres container running within Vagrant as well. So we can initialize Vagrant box, and then in the same way run gun Vagrant apply to set up our Vagrant box with the configuration. And so we can SSH in and check that we're running all of those Docker images. So we've got Ghost and Postgres and all the other Glider Lab services. And so we can connect to Ghost and check that it's running here. And finally, we'll just tear it all down. So if you want to take a closer look at any of the source, it's on GitHub. The top link goes directly to the branch that's committed to. The main repo is under the Glider Labs org. And there's my GitHub as well, if you wanted to take a look at some other stuff. So I think I ended a little early here, but if you have any questions.
Yeah, we have time for questions if you want to line up over here in front of the microphone.
Can you explain again the purpose of Gun, of why you wrote that as a wrapper around Packer and Terraform and Vagrant instead of just using those tools?
So Gun itself doesn't wrap that. So Gun is just a way, like you can define modules of commands. So I didn't get into all of that, but could kind of quickly look at it. So it's a way of wrapping modules of commands. So, when you're working with, say, you have your operations repo and you're going to have standard commands that you're running. This was just a way that we had to define those easily under like one command that you run. And it takes care of some things like the profiles, so that you just save some configuration in a profile and then run it with the sets of commands that you want to run. So different configurations that you want to run is just a separate profile file.
Is Gun open source? Can I look at that as
Yeah,
well?
yeah. The project's actually called Glider Gun. Yeah, so some of the naming conventions, so Jeff Lindsay, who started Glider Labs, is a big fan of Conway's Game of Life. So Glider Gun is something that fires gliders, glider being like where the logo came from and so on. So.
I might have missed the explanation, but it felt like a lot of your recipes could be expressed quite succinctly in like a chef solo recipe or a puppet recipe. Is there a reason you went with the template strategy with cloud in it versus a more traditional CMS?
I think in this case, if you look at it, the code for this is hundreds of lines instead of this complex system that, I guess we just felt like it was easier to kind of just build on those tools and just abstract some of the common things that we were doing instead of introducing another bigger piece of software.
Great. Let's give in the round of applause to Matt.